Hello, my name is Victoria Bryant from Stillwater Sciences in Arcata, and today I'll be discussing our relocation efforts of the listed species Angelica lucida. To accomplish this, we transplanted individual plants as well as collected and spread seeds. I'll be discussing our methods, outcomes, and interesting observations from over our 2-year monitoring period. Angelica lucida, also known as sea watch, is a perennial herb in the family Apiaceae. We'll be discussing the life form in more detail later on. It has a California rare plant rank of 4.2 and can be found on the north coast of California, growing in coastal habitats such as dunes, scrub, and salt marshes. Our relocation efforts were conducted to support the construction of a wetland mitigation area in Humboldt Bay, California in 2018. Our study area is located across from the mouth of Humboldt Bay and west of Highway 101. Pre-construction botanical surveys identified a population of Angelica lucida within and immediately adjacent to the construction work area of the wetland mitigation project. Here you can see most of the population is located on a berm in the central area of the pond, with some individuals growing on the right side. Construction activities took place at a previously developed industrial site just out of frame on the right side of the shot. After consulting with the local regulatory agencies, a plan was developed to try transplanting individuals from this impact area to the opposite side of the marsh and monitor their success over time. And just a note that this photo was actually taken during the transplanting effort in May 2018. So the disturbed area in the foreground is a result of that. Here's a view from the other side of the marsh. The adjacent established salt marsh is dominated by Bulboschoenus maritimus, Juncus lascurei, Disticus spicata, and Salicornia pacifica, which then transitions to a coastal scrub habitat dominated by Juncus lascurei, Symphyotrichum chilense, and Rubus ursinus. Up on that berm there you see on the right. Construction activities took place over to the left side of the frame, and our Angelica lucida plants were transplanted to this berm you see on the right side. In May 2018, Angelica lucida plants with the potential to be impacted by construction activities were identified and flagged. The root ball was excavated by hand and individuals were transplanted in the relocation area. In total, 40 individuals were relocated. There's limited information available about transplanting methods for this species, so transplanting methods were developed based on recommendations for other Angelica species, including some horticultural varieties. Additionally, in August 2018, mature seeds were collected from the adjacent population and were spread by hand throughout the relocation area. Transplanting efforts were conducted by Samara Restoration, a local native plant nursery. And here are some pictures of mature seed heads, just like the ones that we harvested and spread in August 2018. Before digging up the plants, baseline data were recorded for all transplanted individuals, including height, aerial extent, vigor ratings, and photographs. The phenological state of each plant was also recorded as either fruiting, flowering, or vegetative. After the baseline survey and transplanting effort, monitoring surveys were conducted at 3 months, 6 months, 1 year, and 2 years post-transplanting. Angelica lucida individuals within the relocation area were considered successfully established when vigor ratings were greater than or equal to 2. So here's an image showing the pre-construction study area. You can see the relocated plants' original locations in yellow, along with the established population in pink, all within this saltwater marsh. The green wetland boundary inside the relocation area follows a berm comparable to the slightly elevated position where we observed the Angelica lucida occurring naturally. This figure shows the new locations of all 40 transplanted individuals. They follow the line of this elevated berm with some slight variation to cast a wide net and see what worked. And at 1 year, we saw a lot of mortalities during year 1 monitoring. Out of the 40 original transplants, only 8 were alive in May 2019. By this time, we did observe 5 new recruits from seed in the relocation area, though, so not all bad. However, our goal was to have at least 36 established Angelica lucida plants by 2020. And in 2020, we saw really high recruitment. At the time of year 2 monitoring in 2020, we identified 81 recruits from seed in the relocation area, along with 5 surviving transplanted individuals, bringing our total number of established plants to 86, which very comfortably surpassed our success criterion of 36 individuals. Between May 2018 and May 2019, we saw a steady trend of decline in both vigor ratings and overall survival of transplanted individuals. We saw an initial die-off over the first summer of almost half. This was followed by almost half of the remaining healthy plants moving into a lower vigor category and ultimately dying. By year 2, there are only 5 left. The recruits established from seed tell a different story. The first recruit was observed in the relocation area during the 6-month monitoring survey in November 2018, followed by 5 more in the 1-year survey. During the 2-year survey, high recruitment from seed was observed. In October 2020, 3 of the 6 previously identified recruits were found surviving. In addition, 78 new recruits were observed in the relocation area, bringing the total number of living recruits to 81. I also wanted to point out here on the mapped, the mapped recruits observed in the original construction impact area. Before construction activities in 2018, we transplanted all Angelica lucida from this area. So the pink squares you're seeing here appeared between 2018 and 2020. The official monitoring period ended in 2020, but we decided to revisit the site in 2021 to check on the relocated population. So we've got recruits observed in 2021 here in purple, which is good news as it shows the population is continuing to perpetuate. Something else to note is that since the completion of the wetland mitigation work, there are other hydrodynamic functions, including influencing the study area. What used to be a paved asphalt lot to the left of our study area is now a seasonally inundated wetland with connectivity to our marsh in several places. You'll also note that the existing population of Angelica lucida here is expanding. Here's a picture taken in October 2020 during the 2-year monitoring, which characterizes the recruitment we saw throughout the project. Vegetation at this site was consistently dense year-round, and we observed seedlings as well as more developed rosettes. You can also see spent seed heads in the process of dropping seeds. It's difficult to say whether the recruits were a product of seeds dropping from mature transplants or if they grew from seed spread by hand. Additionally, it's possible the seeds came from the established population across the pond, although if that were the case, we would expect that there would have been a population of Angelica lucida plants here prior to our relocation efforts, which is not what we observed. Here's a photo from October 2020. And you can see some seeds of various species, including some of Angelica lucida. Angelica lucida seeds pictured here would have been the product of established transplants in the relocation area, as this was taken 2 years after our relocation effort. And here's another zoomed in view. Next, I'll talk about some observations and the questions they raise relating to the phenology and life cycle of Angelica lucida, which may benefit further restoration efforts. During surveys throughout the 2-year monitoring period, the phenological states of relocated Angelica lucida plants were recorded. In some plants, such as annuals and biennials, phenology plays an important role in determining the length of the life cycle. Such plants will naturally die off after flowering and fruiting. Survival monitoring data suggest that Angelica lucida in our study area may be behaving as a biennial plant rather than a perennial plant, as it's often described. Biennial plants typically take 2 years to complete their life cycle. The first year is characterized by vegetative growth. Once reaching a certain size, usually during the second year, a plant reaches reproductive maturity and produces flowers and eventually fruits. After once reproducing, biennial plants complete their life cycle and die. Our monitoring data are suggestive of a biennial life cycle for Angelica lucida plants in our study. Throughout the 2-year monitoring period, transplanted Angelica lucida plants were usually found to be dead after they were previously observed flowering or fruiting. Out of the 40 transplanted individuals, 26 died without flowering. At the time of transplanting, 8 transplants were observed to be in a reproductive state. 7 of these plants were dead during the 6-month survey in November. Throughout the monitoring surveys, 14 of the 40 transplants were observed flowering or in fruit. Only 2 of these plants were observed living after they'd gone to seed. However, these 2 vegetative individuals were small and appeared consistent in stature with other recruits from seed. So it's possible that they were not actually the originally transplanted individual, but rather the result of natural seeding in the location of a dead transplant. And since our methods relied on GPS data and pin flags to locate transplanted individuals, instead of, say, tagging each plant at the base, we can't say for sure whether what we're seeing is seasonal dieback and regrowth of an established perennial plant or post-fruiting death of the original plant and a new seedling in its place. During our 2021 site visit, we decided to investigate some roots of Angelica lucida plants within our relocation area, to explore these questions. Looking back at this picture, you'll see small seedlings, more robust rosettes, and standing dead seed heads. So here's an excavated root of an Angelica lucida seedling. And here are the roots of a larger, more established plant. Comparing the two, the plants on the right appear more likely to be recently recruited from seed as opposed to a perennial plant that's died back and resprouted. So looking at the roots of a post-fruiting plant was something I was really curious to do. One might expect to find a robust taproot prepared to overwinter, or this lovely decayed and rotting mess. I uprooted 3 similar nearby individuals in a post-fruiting stage and found all 3 to have a rotten and dead roots. Of course, this is just an observation on a small number of individuals, but I believe further study about the life cycle of this listed species would be interesting and informative to future restoration projects. All that being said, what information can we take away from our project to inform future restoration efforts? Given the questionable longevity and limited survival of transplanted Angelica lucida individuals, we recommend not relying on transplanting alone as a sole restoration method. We found seeding to be an effective longer-term strategy. And we also recommend a longer monitoring period of at least 2 years to evaluate the success at a population level, instead of only focusing on the survival of individual plants. So that's all I have today. And I'm gonna hop in the Zoom if there are any questions or comments. So thank you. And enjoy the rest of the symposium.